Hi, this is King of Review. Find the coefficient of x squared from x plus 1 to the fourth power. So what we need to do is expand x plus 1 to the fourth power. And to do this, we'll use a formula called the binomial theorem. So the binomial theorem is a plus b to the nth power is equal to the sum from r equals 0 to n of n CR times a to the n minus r power times b to the r power. So this is the binomial theorem, and this NCR here, this represents the number of possible combinations of r objects from a set of n objects. So let's apply this theorem to our problem. So for our problem here, n is going to be equal to 4, a is equal to x, and b is equal to 1. So I'm getting these values from just looking at our binomial theorem here. And so I'm going to apply these values to this theorem. So when r is equal to 0, here, we're going to get 4c0 times x to the 4 minus 0 times 1 to the 0. And this sigma notation here in our formula, this represents the sum. So we're going to add each of these r equals values. So for r equals 1, we'll get 4c1 times our a value, which is x, to the 4 minus 1 power times 1 to the first power. And we're adding this to our r equals 2 value. So we have 4c2 times x to the 4 minus 2 power times 1 squared. And we're adding this to r equals 3. So we have 4c3 times x to the 4 minus 3 times 1 to the third power. And finally, we're at r equals 4, which is where we're stopping at for this problem. So we have 4c4 times x to the 4 minus 4 times 1 to the fourth power. So we have the sum of each of these. Now what I'll do is simplify each of these. So for r equals 0, we have 4c0. X to the 4 minus 0, that's just x to the fourth power. And 1 to the 0 power is 1, so I don't need to include that there. So plus, for r equals 1, we have 4c1, x to the third power, and then times 1 to the first power. Now, 1 to the first power is 1, so I don't need to include that there. Next, for r equals 2, we have 4c2 times x squared times 1 to the second power. Again, we don't need to include that because it's just the 1 there. And 4c3 x to the first power, so just x, times 1 to the third, which is just 1. And then finally, 4c4 times x to the 0 power, which is 1. And 1 to the fourth power is 1. So we'll leave that as 4c4. So we're asked in the problem to find the coefficient of the x squared value. So where is x squared here? Here's x squared. So the coefficient is the number in front, which is 4c4. 4c2, which is this. Now this represents the number of possible combinations of r objects from a set of n objects. So we're going to use another formula here to solve for 4c2. So when we have NCR, this is equal to n factorial over n minus r factorial times r factorial. So this is the next formula that we'll need to solve this problem. So let's set this up. In this case, this is our n value, and this is our r value here. So we have 4 factorial over 4 minus 2 factorial times 2 factorial. So this works out to 4 factorial over 2 factorial times 2 factorial. So 4 factorial is 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. And then we're multiplying that again by 2 factorial, which is 2 times 1. So next, when we work this out, we get 24 over 4, and this is equal to 6. So 6 is our final answer. Thanks for watching.